Hey everyone, welcome to this part of the Module 3 where we will be looking at how to create different types of engineering drawing views using the SOLIDWORKS. So let's get straight away with the SOLIDWORKS and begin with how to create the sectional view. So we have a simple part here that has a hole and a rectangular slot with the L-shaped cross section, and we're going to make a sectional view for this solid model. So I'm going to go ahead with File, make drawing from this part, choose the drawing sheet, and I'm going to insert a front view here. I'm going to click OK. I can always adjust the scales and the display style for this solid model. I'm going to click OK. Now when I go to the view layout, I can see there's several options of creating the views for the solid model. If I click on the section view, I can see there are 4 different options of creating the sectional view: vertical, horizontal, at an angle, and the auxiliary sectional view. We need to create a cutting line so that the part can be cut or sectioned along that cutting line, and then we can see the sectional view. So I'm going to start with a vertical cut. As soon as I click on the vertical cutting line, I can place the cursor at certain point where we want to create the sectional view. A pop-up window will appear where we can have another bunch of options, including the arc offset or the single offset or the notch. And once we are okay with the sectional cutting line, click OK and move the cursor to the right to place the sectional view. You can notice that there are hatched lines at 45 degrees angle created on certain areas of the sectional cut. If we go back to the solid model, and under the heads up toolbar, if I click on the section view, I can choose either the front plane, the right plane, or the top plane. So depending on how we want to create the sectional cut, in the drawing we've created the sectional cut along the right plane by creating a vertical line. So if you orient the part along the front view direction, so that vertical line is our sectional cutting line as we've created in the drawing. And we place the view on the right side of the front view with the arrow directions going to the left for the sectional view, which means that we cut this part along this cutting line and we create or generate the sectional view, and we're going to look at it from the right side. That is the reason why arrows are pointing in the leftward direction. So if I turn around and orient the object along the right view, I can notice that the colors are different along the different faces. So wherever the sectional cut has been made is colored in a different way than the other colors where the sectional cut hasn't affected the geometry of the part. If I slightly turn around, I can see that these are the rectangular faces where the sectional cut has been applied. And therefore those are the rectangular faces where these hatched 45 degrees lines have been created in the drawing view. So we can verify this from the solid model, that how the sectional view is going to be appearing based on the sectional cutting line that we've created. If I go back to the drawing view, that is where we can confirm the sectional cutting view. Sometimes it's easier to show the sectional views rather than the normal right view or any other projected view because of several hidden lines or the lines available in the geometry that makes it difficult to visualize the dimensions accurately. Let's take a look at another example of the sectional view by creating the horizontal cutting line this time. I'm going to go to the section view, click on the horizontal section cutting line, and again I will create the sectional cut view with respect to the center of the hole. So once I press that line there, click on the check mark, and if I move my cursor to the top, you can notice, depending on the arrows pointed by the sectional cut BB, it will indicate whatever the view is available. If I flip the direction, the arrows get flipped, and now we are looking to the downward direction from the top view side. So once I place the view here, that is what the sectional cut view will appear. Again, I can verify that going back to the solid model. I'm going to come out of this. Let's go back again, and this time I will be using the sectional view along the top line, right? So this was the front view as we've created in the drawing, and we created a horizontal sectional cutting line. So when we look at it from the top downward, that's what the sectional view we can obtain in the drawing, with the light colored rectangular faces hatched in the lines drawn at 45 degrees, and that is the view as we get. So that is about the sectional view. Let's take a look at another example and see how we can create the aligned sectional view. The aligned sectional view is typically used for the objects that has the cylindrical features, and also it is having the axis of symmetry. For example, in this case, once we make the drawing and place the view, let's say we start off with the front view and project it to create the top view. Sometimes it becomes difficult because the way the geometry is created, and once we place the dimensions on the part, it becomes a little unclear as how the dimensions would make sense if one were to create that solid model based on the geometry or the views which are shown in the drawing file. So the aligned sectional view, again, if we go to view layout and go to section view, choose this option which says align sectional view. We start off with the center or the axis of symmetry. I'm going to use one circle for one direction and the other circular cut for the other direction, and then click on the check mark, and I can create the sectional view which is now aligned in a single straight line. So I'm just gonna get rid of this view quickly so that I can make some room for the sectional cut here. So as you can see, this sectional cut AA starts off from the left side of this solid model. As you can see, this hole represented by these two lines here, and comes up to the center, which is this center line. If I create the center line by using the annotation, I can place this center line and clearly observe that this circle or the cylinder at the center, the axis for that is represented by this center line, and this hole on the arm has this center line that is visible in the front view. Then starting from the center, again going into the other direction, which is similar to the first direction, only the difference is that it's present at an angle. We can align them along the straight line, and then it becomes easier to look at the geometry, and also once we place the dimensions, it becomes easier to understand how to create the solid model. So the aligned sectional view is also very important to be created in the drawing. Let's take a look at another example where we will look at how to create the auxiliary view model. In the auxiliary view model, we need to create the views which are normal to the viewpoint of a particular surface. For example, here, if I create the if I go to the orientation and create the front view, we are not able to see that slanted face, which is indicated by the this line at an angle. Also, when I go to the top view, I'm only able to see its foreshortened views, which is not representing the true dimension. And finally, if I go to the right view, again, I'm able to see only its foreshortened view. So I'm not able to see the accurate dimension or the geometry of the circle in either of these three standard orthogonal views, and therefore we need to create the additional view, which is the auxiliary view. There are different ways of doing about creating the auxiliary views. Let's take a look at how we create in the drawing, and then we will come back to learn how to create going from the solid model by creating the additional views. So first I'm going to create the drawing and place the front view here. Click OK, go to annotation, and use the view to first of all create the hidden lines visible. Okay, and then go to view layout, center line, and once we select the view, if it is not appearing, we can always manually do that to place the center line. Alright, so we can go to view layout and then click on the auxiliary view and click on the edge for which we want a normal view to that particular edge. So if I try to merge it here, we can notice that the slanted face is now aligned normal to the viewpoint. So we can place it, and that becomes the auxiliary view. We can always break the alignment by right clicking on that additional view, go to alignment, break alignment, and that way we can keep this view somewhere else if you have the space constraints. But it's always recommended and rather required to keep the front, right, and the top view in the aligned manner. You never want to break the alignment for the front, right, and the front top view. So once we create the auxiliary view, we can click on and we can create the dimensions on the circle. So if I go to annotation, smart dimension, and I can notice that the dimension is indicated for that circle, which otherwise would be indicated by the letter true. So if I go to view layout, projected view, let's say I project this view from the front view and also to the right, and if I try to annotate it, it will say that the true R is 12.5, and here as well the true R is 12.5. But on this dimension it's not going to be saying that because this is the actual geometry that we are able to create using the auxiliary view. If we go to the view layout, we can see some other options such as the detail view. For the detail view, let's say we create a circle. So everything inside that circle that we create will be indicated as the detail view. Some of the times the part geometry is such that there's very small features present which are not able to be seen clearly or created very clearly because of the constraints on the other dimensions. And so in that case we can create the detail view to zoom it in a particular view. Let's take a look at one more example, which is the break view model. Some of the times the situation is that the dimensions in the other orthogonal directions are order of the magnitude higher than the dimensions in the other orthogonal direction. For example, in this case, if I, let's say, use the inches system of units and try to go and evaluate, measure 1.2 inch and 1.54 inches, and the length is 40 inches pretty much. So the dimensions are very high in one of the orthogonal directions, z direction, as compared to x and y axis. Again, if you change the units from the units tab here and try to measure it again, you can see a clear difference. So this is 1 meter and it's 0.03 meter and 0.04 meter. So there is an order of magnitude difference. So what happens is that when we create the drawing for such examples and try to place the let's say the front view and create the side view along with it, we can notice that the cross section is too small. So we would like to create the cross-sectional dimensions or the front view at a larger scale. So I'm going to right click on the double arrows and then click on the properties, and instead of 1/10, let me make it for example 2/3. Just try to make it as a bigger. So the problem of doing that is all other views are also increasing in their scales, and then it becomes difficult to accommodate them. So I'm going to go to the view layout and then click on break view. I'm going to click on the break by first clicking on the drawing sheet and next to this circular hole, and the break I'm going to create right before the second hole. Since there is no change in the geometry or the cross section between these two holes, we really don't need to show that in the drawing, and we can save some space and we can easily accommodate the views next to each other, and it becomes easier to place the dimensions, and that is how we can create the break view. So in this case, once we create the dimensions, although it is a break line here created, the dimensions are shown as the correct dimensions of the actual part or the actual edge. So that's how we can create some of the different types of views which are used in the engineering drawing creation. Thanks for watching, and I will see you in the next video of this module.